Okay guys, now let's go through the local preference. Now, the local preference, let me just jot down some notes over here quickly, but before we forget them. Don't forget that the local preference is going to be a well-known discretionary. Okay, and this is something that a lot of people tend to forget. I'm not sure why. So the well-known piece of it means that it must be understood. So routers have to understand what the local preference is, but it does not have to be applied, or it does not have to be included. Have to be included. Okay, so if you send the local preference to your service provider is going to drop it, right? Your service provider doesn't care. Typically, where we use the local preference is inside of an IBGP network, where maybe right here is our edge, and maybe we want to advertise or send in a different local preference for our outbound outbound route selection. So here, this would be in the outbound direction. Maybe we send that in from our edge routers. Or what we could do on the inbound direction of R1 is we could go ahead and we could change that as well. So you can do this in either way, okay? You can do this per prefix like we showed before. You can do this in any way you like, and I'm going to show you a few different ways, all right? Now, don't forget that the default local preference value is going to be 100. So when we look at our local preference, just like we saw with weight, you know, you have people that go in and say, okay, I want my default local preference to be 500. You don't have to do that. As long as it's higher, because the higher wins, as long as it's higher than 100, you should be just fine. So what we're going to do here is we are going to use autonomous system 1, 2, 3 on our 3 routers here, and hopefully that will allow us to simulate our IGP network. What we're going to do is we are going to redistribute connected, because what we want is we want this network from both R2 and R3 to get advertised in over to R1. Okay, we are going to form appearing with the loopback addresses, and I've already gone in and set up some static routes, so I should be able to ping the loopback addresses to my devices here, and I can get to them. So we're going to be all set. Let's just go ahead and let's get BGP configured. Let's get our routes advertised, and then we can go ahead and mess around with the local preference. So we'll say router BGP 123, BGP router ID 1.1.1, neighbor 2.2.2, remote AS 123, neighbor 2.2.2, update source, loopback 0. We're good. Let's say redistribute connected just now while we're here, so we don't have to wait for the updates later on. So we'll go ahead and we'll say remote 123. We'll actually cheat. I love cheating. Neighbor 3.3.3, and we'll go ahead and we'll just do this. Right, so this should give us a full configuration here of what we need. Do show run section router BGP. So we're pretty good to go here. Let's go ahead to router 2, config T, router BGP 123, BGP router ID 2.2.2, neighbor 1.1.1. remote AS, I don't even know what that was supposed to say, 123, neighbor 1.1.1, update source, loopback 0, neighbor, we're good to go there actually, redistribute connected. And on R3, what we'll do is we'll go ahead and say redistribute connected right off the bat, so that it's there. BGP router ID 3.3.3, neighbor 1.1.1, remote AS 123, neighbor 1.1.1, update source L0. And we have an adjacency. Let's head over to 1. Let's just see what kind of prefixes we're getting. Do show IP BGP. And let's say do show IP BGP summary. We do have an adjacency that's up and running. And so at this point, we just kind of have to wait. So while we wait, I will go ahead and try to talk to some effect about certain things. One of the things, or one of the ways that we can mess around with local preference is with a route map. And that's really, you know, I would say the best way to do it, because you can be more granular. You can go ahead and you can point it to a specific prefix rather than setting the local preference to everything. However, there may be situations where you want to assign the local preference to everything. You want everybody to use R2 as your preferred exit point. And so what you can do is you can change the default local preference. Okay, so these are the 2 ways that we have to really manipulate our local preference, and that worked perfectly because in that 2 minutes we went ahead and we got all the routes we're looking for. Do show IP BGP, and this is what we're essentially looking for, 1024.35. So take a look. we have the default local preference of 100 coming in from our IBGP neighbor, okay? And R2 has been selected as our best path. What we want to do is we want to have R3 become selected. So what we'll do is we'll go over to R3, and what I'm going to do is I'm going to say BGP default, and then the command I'm going to use is local preference, and what I'll do is I'll set this to anything over 100. So I'll set this to 101, and I'll say do clear IP BGP star soft. I'll head over to R1 and I'll do the same thing. Do clear IP BGP star soft, and we'll say do show IP BGP. Now instantly here, we should see, if you check this out, our valid and best next hop has now switched. So up here, the valid and best, the one that was getting added to our routing table, was the one for R2 and not the one for R3. But you can see that the local preference was 100. Now that I've set it to 101, you can see that that's flipped. So now you can see that R3 is now the valid and best hop. You can see that this guy's now being added into our routing table. Again, I see folks sometimes go to obnoxious numbers. They go in and they say 180 or 510 or whatever they want to set it to, and it's really just the higher number. So if you want to change this to something that stands out, like a 200 or a 300 because you want to be able to stand out to your eye, that's completely fine. That makes sense. But if you're just doing it because you want to make sure that it's the highest, well, you really don't need to go that high. It just needs to be the highest, right? But again, notice what we did with R3. By setting our default local preference, we went in and we actually set all of the routes from that individual router to now have the higher local preference. So again, in this network, it's a small network. It doesn't really matter. We don't have a lot going on. And so, our problem here is not really that significant. Although in a real network, if you go ahead and set your default local preference, that may or may not be a problem for you. If these routers here, R2 and R3, are edge routers, and you want R3 to always be selected as your exit point to get out to the internet, then yeah, you can go in and set your default local preference. Not a big deal. But what if you only want that local preference to maybe be what if you want that local preference to only be for certain prefixes and not everybody? Well, here you may have some different, you may need to add some route maps and whatnot, and that's really what we're going to do. Now, what I'm going to do is I did create a route map before, so I'm going to say no route map, and I believe it was called wait. So let's say do show run section route map. This was right after the wait video, and I still should already have an access list in here. So if I say do show run section access, you can see that I have an access list that's already set up for this prefix 1024.35.0. So what we're going to do is, rather than recreate this, I'm just going to leave it, and we're going to reuse this ACL, and we're going to create a route map that says basically only for this network do I want you to increase the local preference, okay? And so what we're going to do is, now that R3 has the higher local preference for every network, what we're going to do is we're going to flip this back over to R2, and we're just going to flip this guy back over to R2. We're not going to flip over everybody, just this one network, okay? So we'll go ahead and we'll create a route map, and we're going to call this local_pref permit 10. Those of you guys that have watched any of my configurations before, you guys know that I like to create my route maps based on the attribute that I'm actually tweaking. That way, there's no question as to what that route map is doing. I usually like to name them a certain, that way. So I'm going to say set local preference, and what I'm going to do here is I'm going to say set local preference to 102. I'm not really going to go that much higher, so the default is 100, and I'm going to go ahead and say, okay, this guy's going to be, R3 is going to be 101, so all I'm going to do is tell R2 to be 102. Now, right here, I'm going to go ahead and I'm going to hit exit. Those of you guys might be shaking your fists at me. Don't worry, I did it on purpose. So those of you guys that aren't clear exactly what I'm talking about, don't worry, we'll get there. Router BGP. What I'm going to do is I'm going to apply this route map here that I just created. So this, let's say do show run section route hyphen map. This route map that I just created here, that's going to look for the prefix in ACL1, which is this prefix here, is going to go ahead and set, anytime we see a match on that ACL, it's going to set that local preference to 102. All right. So what I'm going to do is I'm going to go ahead and say neighbor. Actually, I can just copy and paste it. I can just say neighbor 2.2.2. And I can take this route map local preference. We'll copy and paste that. And all I'm going to do is say in. Let's say do clear IP BGP star soft. Okay, and so now what we can do is say do show IP BGP, and let's see what we've done. Well, we've completed our task, but we've also broken something. Okay, so let me scroll back up here, and you guys should be able to identify pretty quickly about what we've broken. So here, if we look at this network, the valid and best was R3, right? Here was the next hop of R3, had the local preference of 101. So if we scroll down here, what did we do? We flipped that. So here's our valid and best now for that network. It's going to the next hop of R2, and the best local preference is 102. But notice how the next hop of 2.2.2 is only listed for this network. It's not listed anywhere else. Scroll back up here. We had the loopback of R2. We had the connected network between R1 and R2. We had the connected network between R2 and R4. Now we don't have any of these. So what's the problem? The problem is in our route map. So we're going to say section route hyphen map. The problem here is that at the end of every route map, there is that implicit deny. There's, hey, deny everything else. Okay, so because in this route map, what we basically said was match this ACL and then set the local preference, it ended there. And the route map basically said deny everything else. So what we're going to do is we're going to add this route map local pref permit 20. And what that's going to do is the first half of the route map, so the first piece, which is at 10, this is going to get applied first, is going to say match everything that's in ACL 1. It's going to look into that ACL and say, okay, I see these prefixes that I'm supposed to match on. I'm going to go ahead and set the local preference for those prefixes to 102. Then I have the second piece of the processing. The route map says, okay, well, I have all these other prefixes. What am I supposed to do with them? This route map piece being blank is just going to allow them to be processed and allow them through with no problem. And let's say do show IP BGP, because in the time it took me to explain that, we probably got more updates, and there we have it. So if you look here, the prefixes that are coming in, the 192.168.2s, these are loopback addresses hanging off of R2. They're coming in with a default local preference of 100. If I take a look here, the network in between R2 and R4, the 1024 network, is coming in with 100. The only network here at this point that is coming in with a local preference of 102 happens to be R2. So that is how we can apply this local preference. And we can also do it in the outbound direction if we want to. So I should have an ACL here. Let me just check. No, okay. So what I'll do is I'll say, let's not even worry about an ACL. Let's just say route map, and we'll say local pref. Okay. And we'll say set local preference, and what I'm going to do is say let's actually say 200 so it stands out. Do shall run section route map, or router BGP. Sorry about that. And let's go in here, and what I'm going to do is I'm going to apply this here to my neighbor in the outbound direction. So we'll say do clear IP BGP star soft. We'll head over to R1, and I'm going to say do clear IP BGP star soft, and I'm going to say do show IP BGP. Okay. Now, if you look at this, something very interesting happens. And that interesting thing is that all of the networks attached to R2 are now being sent. They're now, all of the updates that we are receiving, we are getting a 200, okay? But notice this one network here is still getting the original 102 that we applied. That's because whatever local policies I apply here on R1 are going to take precedence over what I'm being sent. And this is what I was saying before, that, you know, it's an optional discretionary. We can do with it what we want. And so R1, because R1 is applying a local policy, tweaking the local preference for this network, R1 is winning over the local preference that's being set, or sent rather, from R2. But if I change that, if I go in and say, if I go into my BGP instance here, and if I remove this route map, and I say do clear IP BGP star soft, and then say do show IP BGP, what we should see is that now this guy has a local preference of 200. So we can either set this local preference either inbound or outbound. We can set it via route map. We can set it based on the different number of prefixes, or we can set that default local preference like we did on R3. And since it's been a couple minutes here, let me just quickly show you that. Do show run section router BGP. The command's in front of you anyway, but that's all right. So here we can say BGP default local preference, and what that's going to do is that's going to affect how and what value we set or we send with our updates. So every single update that R3 sends out is going to send it with a local preference of 101. And again, this is where we would how we would dictate which edge router we might use to get out to the internet. So again, guys, with the weight, I hope this kind of shed light on this attribute and kind of what you can do with it, how you can set it. I wish I had this when I was studying. I wish I had a video like this, to be honest with you. But you know, it is what it is. So I hope you guys can use this to your advantage. Take care. Happy studying. I will see you guys in the next one, which I believe will be AS Path.